Okay, good morning. We continue the last this lesson again. We need to complete something. But before doing that, if you remember, I gave you a problem we were supposed to solve. So we were supposed to find this logarithm of tangent of 1 degree to the base 2 plus logarithm of tangent 2 degrees to the base 2 plus the logarithm of tangent 3 degrees to the base 2, and then we continue this list until we reach to tangent of 89. Okay. We were supposed to find this sum. So do you have any ideas what to do? Yes?
Since it's a logarithm, you can just do the product of all those tangents.
Yes, we had the formula. What you are referring to is this formula. Let me write it with a different color. So if you have a log x to the base a, say, plus log of another number, probably y, to the same base added, you can write one log with the same base, but then you multiply these two numbers, yes? So somehow logarithm transforms the addition to multiplication by this rule. So that was the rule that you need to know for solving this problem. Of course, here I have written the formula only for two numbers, x and y, but you can write it for three numbers, four numbers. But what is important is that if you want to use this formula, the bases of these should be the same, otherwise we cannot do that. Of course, here, fortunately, all the bases are two, yes? So you can do that. Okay, but how this will help? So let me follow what you told me. So this is my question mark. So this question mark is equal to. So all of these are logarithm to the base 2, and then I have addition. So according to what we described here, we can write 1 log of 2, but instead, what can I do now? I start multiplying the numbers in front of the logs, yes? So this becomes tan of 1 degrees multiplied by tan of 2 degrees multiplied by tan of 3 degrees, and then it continues until tan of the last one, 89 degrees. Okay, so far so good. Okay, then? Yes?
If you multiply the tan of the complementary angles, you get 1.
Yes, so that was a very important thing that we learned last time. I really want you to remember, send it to your memory. So if you have two complementary angles, let us review fast. What are two complementary angles?
Two angles that, if you add them, you get 90.
90 degrees. So those are called complementary angles. And when we had some rules for sine and cosine, we also had some rules for tangents. Yes, what was the rule for sine and cosine? Sine of one of them is equal to cosine of the other one, and cosine of one of them is equal to the sine of the other one. That was the relation for sine and cosine. We also had a relation for tangent, and that was what? The tangent of complementary angles are reciprocal. So if one of them is 2/3, the other one is 3/2. Yes? So it means that if I multiply them, it becomes 1. Yes? So this means that you have to be a little bit creative to organize this product in a different order. Because if you want to multiply a bunch of numbers, it doesn't matter in which order you're multiplying them. Yes? So what you do, because you need to also write properly, so you just write log to the base 2, and then say that, okay, I put these tangent of 1 degrees multiplied by the last one together. The motivation behind that is that 1 degrees and 89 degrees are complementary angles, because when I add them, it becomes 90 degrees, okay? And then, for example, like this, and the next one is tan 2 degrees multiplied by which one? The one before the last one, which is tan 88 degrees, yes? I hope that now the idea becomes clear, yes? And then I can have, for example, the next one, 3 degrees, yes, multiplied by tan 87 degrees. And then I can continue this list. Okay, can you tell me what should I write at the very end? Yes?
Tan 45 degrees because that's what's left.
So 45 degrees will be left alone. Yes, is that clear? Because how many terms are there from 1 to 89? So that's an odd number. So of course it is clear that I cannot group them in groups of 2. Yes, one will be left. Do you agree with me that is left is just tan of 45 degrees? Yes. So in principle, if I want to continue this list, I can continue until tan 44 degrees multiplied by tan 46 degrees, but then multiplied by tan 45 degrees. Sorry for the mess a little bit. Okay, so first of all, tell me, are you happy with what I've written here? Do you agree that what I have written here in here is exactly the same expression here, written in different order? Okay, is that clear? So the order does not matter when I multiply, of course. And now, the idea was that I group them in a way that each pair of angles is a complementary angle. So if I ask you what is the answer to this, according to the rule that we discussed last time, it's 1. If I ask you what is this product, that's 1. That also is 1. This also is 1. Then we have a little bit of problem might be here, but of course that's not a problem. I don't know, do you remember what was tan of 45 degrees? That's one of the famous angles. If you don't remember, you can, what is that? 1. So it is accidentally 1 itself. It is itself 1. So then it means that if I ask you what is this product, that product is a product of a bunch of 1s. So that at the end it becomes 1. And then what happens? So this becomes log of 1 to the base 2. And this log of 1 is famous. Do you remember from Math 2C? What is log of 1? Yes?
0.
It is 0. Yes? Why is that? Because when you say log of, for example, 16 to the base 2, it means that can you give me a number so that when 2 is raised to that number, the answer becomes 16. Of course, in this case, the question mark is 4. And this is the same thing. Can you give me a number so that when 2 raised to that number, the answer becomes 1? So if you remember, 2 to power 0 is 1, so the answer becomes 0. Is that clear? Okay. But I want you, because I told you that for this course it is extremely important to know GeoGebra. But before doing that, let us say that you want to calculate this by GeoGebra. Of course, it is boring if you want to type all of the terms one by one. So you need to find a way to do that. Do you remember what was the previous problem similar to this we solved? What was that? Do you remember? It was sine of 1 degrees, or am I right? Yes. Degrees to power 2. And then we had sine of 2 degrees to power 2. And then we had sine of 3 degrees to power 2. And then we continued until sine of 90. Is that right? Do you have it? Yes? Okay. So do you remember what was the number we calculated? 45.5 or something? Yes. So it is 45.5. This is the answer we got by the calculation. I hope that you remember what we did before. But now my goal is to calculate this using GeoGebra. So I want you to understand how to do that. Okay, of course, one way is to type everything, which is boring. The other one, have you learned about the sigma notation? Yes, the sigma notation for the sum. So for example, you probably should have seen it in Math 1C, yes? So if you have sigma, do you recognize something like this? Okay, so that's a sigma represents sum. Okay, so for example, if I say sigma A, and I put an index for it, whatever, so let us say I is called the counter of my sigma. So then I can run I from an integer, for example, say 2, to some bigger integer, say, for example, 5. Okay? Whenever you see this, it means that you need to replace the counter by these numbers one by one and add them up. Yes, so that's the meaning of this symbol. It's not just a very big thing. So here I replace I with the first number 2, it gives me a sub 2. And then I go to the next step, I becomes 3. I replace it, it becomes a sub 3. I go to the next step, I replace it with 4. I go to the next step, I replace it with 5. Then I have to stop because I don't need to go higher than 5. And then what I get, I add them up. Yes? For example, if I ask you, what is the value of this sigma? Sigma, say, n 2n plus 1. And then I run n from -1 to 2, for example. Okay, what does this mean? It means that whenever you see a number and a letter here, it means that that is the counter of your sigma. So this means that go here, replace the counter with the lowest limit, and then replace it with the next one, replace it with the next one, and then up to the last one, and then add them up. Yes, so what I do first, I replace n with -1. Then I replace it by the next integer. What is after -1?
0.
0. So this becomes 2 times 0 plus 1. And then I replace it with 1. And then I replace it finally with 2. Yes, but then this sigma means sum. Yes? So that is just a notation that I'm introducing you. If you insist to calculate, of course, this becomes -1, this becomes +1, this becomes 2, 1 is 3, this becomes 4 plus 1, 5, and the answer becomes 8. Yes? For simplicity, first let me use GeoGebra to calculate this. The only difference is that instead of sigma, GeoGebra writes sum. I think with capital S we will discover. And then what you put in front of the sum is this expression. The next thing is the variable, is the counter. Here, what is the name of the counter? Is n. So you introduce to GeoGebra that n is the counter. And the next one will be -1. The next one is 2. And you don't need to memorize the format. It will help you. But you just need to remember you want to add. When you want to add, you need sum. And as soon as you start typing sum, it gives you some suggestions and then you can choose from the list. Okay, so let us just do this one first. And then I want you to help me to do this one and that one in GeoGebra to see if you have done things correct. Okay, so let us go to GeoGebra now. I want to calculate what I told you. So I just start typing sum. So you see, I get a sum, and then on the sum, I have more lists here. So this is the one that we want to use. It says sum, write the expression, give me the name of the variable, give me the starting value, give me the end value. Yes? So I just choose this from my list. And then I start completing this. So what was my expression? It was 2. I really recommend you use the product sign. Sometimes it get confused, I don't know why. So 2n plus 1. That is my expression. Yes? The next one is the name of my counter. Yes? In this case, it is obvious that the only counter is n, but in more difficult problems, you have more than one variables, and one of them is the counter. So you have to introduce, okay? So anyway, we introduce n. The starting value was -1, and the highest value, the upper limit, that is called the lower limit, that is called the upper limit. So that's 2, and the answer is 8. Yes? So that is what we did. Is that clear? Okay. Now, I want to do that sum here for you. So the sum on the top. So what should I write? First, let us go to the board. Can you write it here for me? So, can you write this as a sum like this? If you want to write it as a sigma, in mathematics we write it as a sigma. How do you write it? You write a sigma. Can you write it for me? You need to give me a general formula that starts generating these terms one after the other. Okay? So can you tell me, if I want to write with the sigma notation, what should I do? Yes?
So you write the expression sin n degrees to the power of 2.
Yes, n degrees to the power of 2. And then you are saying that this is your counter. So where Where is the starting value for n? What is the starting value for n?
1.
1. What is the highest value?
90.
Is 90 degrees. Sorry, it's 90. Yes? So everyone agrees that what I have written here is the expanded version of this compact notation. Is that clear? Okay, so now we have to do the same thing for this one. Of course, hopefully it becomes clear, and hopefully we have done everything right. So what we do, we go back here. So I press the sum, and then I get a sum, and then you realize that this is the last one that I have to choose. So, but for typing this, you have to be a little bit careful, because in GeoGebra, I told you, do you remember I told you that this symbol means what? This symbol means sine of n degrees, then to power 2. So in GeoGebra, you have to type it in that way, okay? So here I will say sine, yes, so it gives me sine. You see, I choose it from the list, or you type it, and then n. For degree, be careful. So you go to this virtual keyboard, f of x, and then you choose degree sine here. Yes, is that clear? I just write sine n degrees. And then I come back here, but I want to raise it to power 2. So I open a pair of brackets, automatically GeoGebra closes as well, and then I raise it to power 2. So power 2. I really want you to be able to type this yourself, okay? It is extremely important to practice about this. What is the name of my variable? You chose it n. What is the starting value? Is 1. And what was the end value? Hopefully we haven't done something wrong. 90. And the answer is 45.5. So what we calculated was actually correct. Okay? So what I want you to do, for example, at home, try to solve this one using GeoGebra again. It just tells you how to practice these things. Is that clear? Okay. Show you the formula table. We want to complete this together as an exercise, okay? Okay, so here, actually, do you remember we completed this column, this, and that. Even more, we had 270 degrees and 360 degrees. But now you see there are other numbers here. It's good that you have access to them. So, but I want you to learn how to do them, because I see the exercises in the book are related to this. Forget about this radian one. You haven't studied this radian yet. Only working with degrees. We want, for example, to calculate some of them as an exercise. Okay, for example, we want to be able to calculate a sine, cosine, and tangent of 135. And then we want to see that is it the case that we are getting these numbers or not. Okay, so let us concentrate on 135 here on the board. So do you have any suggestions for me? And you can see this. This is given to you in the exam, always. And then you want to calculate for me sine of 135 degrees. Let us concentrate only on that one. Of course, you see the number is 1 over square root of 2, but we want to understand that. So how should I do this? Yes?
Using the unit circle.
Yes, this is the first thing. Yes, I want to talk about sine of 135 degrees, so I have to go to the unit circle. Yes. Okay, so and then 135. So I always start from here as usual. I start rotating 135 degrees about the origin. So when I rotate up to here, it's not finished yet. It is 90 degrees. How much more should I continue? 45 degrees. So I become exactly in the middle here. Yes? So this, you can solve it in two different ways, okay? One way, both of them are correct. So can you tell me what are the coordinates of this point? How they are related. So let me say the coordinates are x and y. Do you see any relation between x and y? One relation, of course, is always what?
X power 2.
X squared plus
Y squared.
y squared is 1. So this is always. Okay? But because, of course, 100, do you remember how much I continued? 45 degrees. So it is clear that now this point is exactly in the middle of this arc. Yes? So can you tell me what is the, of course, x and y, can I say x and y are equal?
Yes.
Can I say? Be careful. No. Why is not?
X is minus.
Yeah, because x is in the negative x part, y is in the negative positive y part. Yes, so y is positive, x is negative. So definitely they cannot be exactly equal. But what is the relation between them from length point of view? I hope that you agree because this is exactly in the middle. From length point of view, this length and that length are equal. But the coordinates are not equal because one of them is positive, the other one is negative. So if this happens, what should I write for x and y? How they are related? Yes? Yes, exactly. So x and y are opposite to each other. Yes? So it means that I have x equals to minus y. Okay, then I have, how many unknowns I have? I have two unknowns. How many pieces of information do I have here? 2. So I can, in principle, be able to solve. Yes? So what can I do, for example? Instead of x, I put minus y to the power of 2 plus y squared is equal to 1. Then this becomes 2y squared is equal to 1. So y squared becomes what? 1/2. Y becomes plus or minus 1 over square root of 2. Yes? But can you tell me which one is acceptable here for y? The positive. You don't need to raise your hands. Please just say it. So y, the positive one. Yes? Because we are in the second quadrant, and the second quadrant is clear that y should be positive. Yes? So this means that I have to accept the positive one. Okay, if I accept that y is 1 over square root of 2, x is negative of y. So what happens for x? Minus 1 over square root of 2. Yes? And then, do you remember what is sine? Sine is related to x or y?
Y.
Y. Sine is y coordinate. Y coordinate is 1 over square root of 2. And cosine is related to
X.
x coordinate. So it's negative 1 over square root of 2. And then tangent is what? Is y over x. Do you remember? So y over x, they are opposite of each other. If I have two opposite numbers, when I divide them, it becomes negative 1. And those are the numbers that we have there. Is that clear? Okay, this is one way, but I want you to learn a different way. Okay? So, from the list of tables that we have here, I hope that you agree that 135 degrees and 45 degrees are somehow related. Yes? Okay, so let us go back here to the board. So if this is 135 degrees from here to here, let me myself draw 45 degrees as well. Okay, this is 45 degrees. Okay, so now do you agree that if I draw this angle 45 degrees and if I draw this angle 135 degrees, this point and that point are mirror image of one another?
Yes.
Is that clear? Okay. If I ask you using this column, okay, 45 degrees, can you give me the coordinates of the red dot on the board? Look at that and give me what should I write here? What should I write for the x coordinate?
1 over square root.
Yes. X coordinate is the cosine of 45 degrees. So it is what? 1 over square root of 2. And if I ask you what is the y coordinate? Y coordinate is
The sine.
the sine, which is in this case 1 over square root of 2. Okay, now this point and this point are mirror images of one another with respect to the x-axis. Now, using these numbers, can you read these numbers for me? You see, this one is this one is the mirror image with respect to the y-axis. So what happens for the x value? It becomes negative of the x value. And what happens for the y value?
It's the same.
It does not change at all, yes. So that's also one way to do this. Okay? Let me also give you a terminology. So what is the sum of 135 degrees and 45 degrees? It's 180 degrees. Okay? There is also a name for it, this pair. That's called supplementary. So if two angles add up to 90 degrees, we call them complementary. If they add up to 180 degrees, we call them supplementary. Okay? Okay, let us practice a little bit more. For example, let us just do this one as well, okay? This second method is actually superior to the, because 145 degrees is a very special case. The point lies in the middle, we can say something. So I solved this in two different ways because I just wanted to review things. But the second method is the important method I want you to learn. Understand what is going on, being able to connect different angles, and then use symmetry arguments to read the coordinates and then find sine, cosine, yes? Tangent. Okay, I want to give you a little bit of time, 2 or 3 minutes, so that you can do this one yourself. Can you do for me 150 degrees? I want you to be able to find sine, cosine, and tangent of 150 degrees using the second method. Okay. So we want to solve that problem. Could you solve it for me? So we want to answer these questions. Sine of 150 degrees. I'm sorry. Cosine of 150 degrees. And then tangent of 150 degrees. So do you remember we calculated for 30 degrees, 45 degrees, and 60 degrees. I showed why why these are correct, as we see in the table. But we didn't discuss about 150 degrees. We want to discuss it now. So why those numbers in the table are correct. Okay, so the first thing that you do as usual, you need to imagine the unit circle. Yes? X and Y. And then you need to find the final point corresponding to 150 degrees. So you start from here, and then you continue rotating 90 degrees. How much I should go more? 60 degrees. So something, for example, like this. Let us assume that this is the correct point. So let us say that this is 150 degrees. Okay, can you tell me which one of those angles, 30 degrees, 45 degrees, or 60 degrees, somehow is a good candidate to solve this problem?
30 degrees.
Yes, Theo? 30 degrees, okay? Why did you understand that? Because you know that if this is 150 degrees, how much is left here? 30 degrees. The size is 30 degrees. And then it means that if I choose 30 degrees here, yes, then I hope that you understand immediately by symmetry, this point and that point are mirror images of one another with respect to the y-axis. Do you understand that 60 degrees is not a good candidate? Yes, because this angle is 60 degrees. So if I choose 60 degrees, it goes higher. And there is not a good relation between these 2 points. Yes? So this is why 60 degrees is not a good choice for solving that problem. 30 degrees is good. Is that clear? Okay, now using the information for 30 degrees, you should be able to give me the coordinates of these points, of this point. What are the coordinates? The x coordinate should be what? 1 over square root of 2, because the cosine of 30 degrees is square root of 3 over 2, yes. And then what is the y coordinate? Is the sine of 30 degrees, which you can read is 1/2. And then when you have these, numbers, you can immediately read these numbers. So what are they?
Minus.
The x coordinate is flipped. I mean, it's reversed. It's the opposite number, and then the y value remains the same. Okay? So now if I ask you what is this number, it is the y coordinate. No, sine is related to the y coordinate. So it is 1/2. So if I ask you what this number is, what's the answer? Minus a square root of 3/2. And if I ask you what this number is, I have to divide y value by x value. In this case, these are gone. I am left with minus 1 over a square root of 3. And those are the numbers that you see here on this column. Yes? So this is important to learn how to use the unit circle and the symmetry arguments to be able to solve that. Sorry. Okay. I want to solve a little bit harder problem. So let us just show it to you. So we want to solve this problem. So if you can solve this problem, it means that you really understood what is needed for what I have said. It means that you have a good understanding of what is going on. So without the help of a calculator, or of course Geogebra or whatever, we want to show that this is equal to this. So we want to know sine of 200 degrees plus 2 times sine of 160 degrees minus cosine of 70 degrees plus 3 times sine of 340 degrees minus 4 times cosine of 110 degrees is equal to sine of 20 degrees. And none of these angles are the angles that you can find in the table. Okay? So do you have any idea how we should do that? You can think a little bit. I can write it here on the board. Okay, so here I have written it on the board. I want to hear from you, what is your idea? How do you think we should solve this problem? None of these angles are the angles that we have them in the table, because the formula sheet is always with you, okay? So you can use it whenever you want to, but this is not allowed to use the calculator or any digital tool here. So how can you convince yourself that the left-hand side, whatever it is equal to the right-hand side? Yes?
Did you look at the unit circle and then find the other?
Yes, you're right, but can you elaborate a little bit more? So for example, how should I look? So which angle is the angle that you want to connect these angles to? Because for example, if I ask you, okay, let me draw 200 degrees, it will be somewhere. Okay, then do you want to relate 200 degrees to what? So let me just follow what you said. So your starting point is correct. We have enough experience in doing that. Okay, so I draw the unit circle here. And then you say 200 degrees. So I start from here, up to here is 90 degrees, up to here is 180 degrees. So I have to continue a little bit more. Yes, so let us say this is 200 degrees. Okay. In the previous case, I had 150 degrees, which I didn't know. And then using this symmetry argument, I connected this angle to 30 degrees, and I had the information I needed for 30 degrees. Now my question is that, which angle do you want to connect 200 degrees to? Yes, Nathan? 20 degrees, yes? This is what is the motivation behind that? Because you see that on the left-hand side, I have a lot of angles, different angles. But on the right-hand side, I have one single angle, and that is 20 degrees. So it gives me a strategy to think. The strategy is, can I connect all these angles somehow to 20 degrees? Because if I can connect all these angles to 20 degrees, I will not be able to see the full solution in my head. But I would say that my strategy might be reasonable. Why? Because on the right-hand side, I have only one angle, 20 degrees. If I succeed, there is a big if, of course. If I succeed to connect all these angles given here to 20 degrees, at least I can take the left-hand side and write it only in terms of 20 degrees. It means that it will increases my chance to solve the problem. Is that clear? So if you give me this problem, I haven't seen that, this is the way that I think. But of course, this is a strategy. Then I have to follow my strategy. Sometimes it works, sometimes I get stuck in the middle. Then either you give up, it depends to your personality, or you are stubborn and then cross it over and go back and find a new strategy. But don't try to do things randomly because it doesn't work. Yes? So my strategy is to connect all these angles to 20 degrees. This is my strategy. I have to stick to my strategy until the end of the problem, unless I realize in the middle this is not a good one. Okay? Okay. Now, this is 20 degrees. So this is 200 degrees. So how can you connect this one to 20 degrees? It is not that hard now, yes? Because when you go up to here, it's 200. Can you see 20 degrees somewhere here? Where is to 20 degrees? It is clear that this angle is 20 degrees. Yes? Okay. But this is the size of the angle 20 degrees. What is the real 20 degrees? It should start from here. Yes? So you start from here and rotate 20 degrees. Do you agree you will end up exactly in the opposite point of this one? Yes?
Yes.
Is that clear? Okay. Now, if I ask you, what are the coordinates of this point? What are the coordinates of this point? The x-coordinate is cosine of 20 degrees. The y-coordinate is sine of 20 degrees. Do you know that? Yes. Okay, now can you read the coordinates here for me here? What are the coordinates here? Whatever these numbers are
the negative.
negative of that. So it is minus cosine 20 degrees and sine minus sine 20 degrees. Do you agree?
Yes.
Okay. Now, can you finally tell me, if I ask you what is sine of 200 degrees, what is your answer? This is the final point for 200 degrees. I am interested in sine, so I have to read the y-coordinate. I read the y-coordinate. What is the y-coordinate? Minus sine 20. Okay, so I couldn't find the numbers, but I realized sine of 200 degrees, whatever it is equal to negative of sine 20 degrees. Is that clear? Okay. I don't want to solve the problem immediately myself. I want you to do some of them yourself. Okay, now please try to concentrate on the second term and try to somehow find the connection between sine of 160 degrees to the angle 20 degrees. I want to see if you can do it or not. Just do it, because you will not learn if you don't do it. Might be you need to clean and draw another picture. And you don't really need to be very precise and very organized in your pictures. As far as you can convince that it's correct, it's good. Okay, please don't stop. If you did this one, go to the next one. Don't waste your time. If you can do things faster, please do that. Okay, so to make sure that you're on the right track, if you understood what is going on, you don't need to listen to me. You just continue yourself. But if you're a little bit shaky still, so let us just do it again. Okay, so the next angle is 160 degrees. We understood that I want to connect all these angles to 20 degrees. Okay, so let me keep 20 degrees and clean 200 degrees. Yes? Okay, so the next angle is 160 degrees. So what should we do? I need to find 160 degrees. Where do you think I will end up for 160 degrees? Do you agree with me? It will be exactly the mirror image of that point, yes? So this means that if I go 160 degrees, because what is left for me is 20 degrees, I have again the same symmetry. Now, can you read the coordinates here for me? These are cosine 20 degrees, sine 20 degrees. If I go here, the x will be -1, but the y value will remain the same. Okay? Because I am interested in sine, I don't even need to waste my time for the first one, but I can, of course, write it. It's minus cosine 20 degrees and sine 20 degrees, yes? Now, if I ask you what is sine of 160 degrees, you will tell me, I don't know the value, but I know it is equal to sine of 20 degrees. What the value is, we don't care. Yes? Okay, cosine 70 degrees. So now I clean this one because I don't need it anymore. My strategy is still the same. So I will keep 20 degrees, but now I want to go to 70 degrees. So where is 70 degrees? I have to start from here. I have to stop before 90 degrees. How much before that?
20 degrees.
20 degrees. So these are good to know. This is a little bit more tricky here, okay? And I will tell you a rule, okay? So can you tell me with respect to which line these are mirror images of one another? So let me solve it in two different ways. Let me draw it a little bit more carefully. So from here to here is 70 degrees, yes? So what is left for me here is exactly 20 degrees. Okay, now I want to read the coordinates of that point, if I know the coordinates of this point. So can you understand that what is going on? Because if I draw that line, do you agree this line, this length is this number? And do you agree with me if I draw this line here, of course my picture is awful, but if I draw precisely, because this is 20 degrees, that's also 20 degrees, these two triangles are exactly identical, they are congruent. So this means that if this length is whatever, this length would be the same.
Yes.
Yes? So now, if this length is cosine of 20 degrees, what is this length?
Sine of 20.
No, what is this length? No, this length is cosine of 20 degrees, and this length is equal to this length. So this length is cosine 20 degrees, but this length plays the role of y coordinate. Yes? So this means that cosine 20 degrees goes here. Yes? And then similarly, what sits here? Sine of 20 degrees. So we are done. Okay? So if I ask you what is cosine 70 degrees, the answer is sine of 20 degrees. But you could do it much faster. Do you remember? Because 20 degrees and 70 degrees are complementary angles. So cosine of one of them is sine of the other one. Try to use all these information that you know. Of course, if you remember, that's good. So it is even faster. I don't really need to go to the unit circle anymore. Okay, sine of 340 degrees. So let me clean this one now. So 340 degrees, where is 340 degrees? So I start from here. If I go one full round, it is 360 degrees. So I have to stop before that. How much before that? Exactly 20 degrees. So the person who designed the problem designed it in that way. So that's not very strange. So I have to, this is the angle 340 degrees. And then you know from size point of view, not direction. This is also 20 degrees. Yes? So now, can you read the coordinates of that point? If you know the coordinates of that point. This time the x-coordinate remains the same, so it becomes cosine 20 degrees, and the other one becomes minus sine 20 degrees up. Agree? And now, which one I want? I want sine of 340 degrees. What's the answer? Is minus sine of 20 degrees. Yes? And finally, what happens for cosine of 110 degrees? So cosine of 100 degrees, 110, from here to here is, let me clean this. From here to here is 90 degrees. Yes? From here to here is 90. I have to go a little bit more. How much more? 20 degrees. Okay? So what happens here? Can you read the coordinates here for me? So if I draw this triangle and that triangle, they become congruent. So if this length is cosine 20 degrees, this length is still cosine 20 degrees, but this will play the role of the y coordinate, yes? Okay, but now be careful. This length is how much? Is sine 20 degrees. So this length is also sine 20 degrees, but what is the x coordinate? Negative sine 20 degrees, yes? So then it means cosine 120 degrees, 110 degrees is equal to what? Minus sine of 20 degrees. Okay, so it seems that the strategy we had in mind is working because I was able to express all those angles in terms of the angle that I need, and that's 20 degrees. Yes? Okay, now you want to prove this. So this is equality. You want to prove an equality. You would write the left-hand side is equal to. Instead of sine of 200 degrees, I can write minus sine 20 degrees plus 2 times sine of 160 degrees is exactly equal to sine of 20 degrees. Yes? Minus cosine of 70 degrees, which is minus sine of 20 degrees. 3 times sine of 340 degrees. So it becomes plus 3 times negative sine of 20 degrees. Yes? And finally, minus 4 times minus sine of 20 degrees. Yes? Are you with me or not?
Yes.
Okay. Okay, then the next thing is just simplification. So let us just do that. Here, it's equal to minus sine 20 degrees. This becomes plus 2 sine 20 degrees. And this is minus sine 20 degrees. Of course, I really don't need to write everything. You can do it faster, but let me just try to write everything. Yes, for example, here I multiply these two, it becomes positive. Now let us see what happens. Minus sine 20 minus sine 20 becomes minus 2 sine 20, and there is a positive one, so all of them are gone. Yes? And then what is left for me here? I have 4 sine 20, 3 of them are gone, so what is left? 1 sine 20, yes? So this becomes sine 20, and this is the right-hand side. So I started from the left-hand side, and I was able to show that the left-hand side is equal to the right-hand side. Okay? One thing that I want to mention is that might we consider this a hard problem? It is not a hard problem, okay? If you think in this way that I told you, in the book you might see this, okay, show that this is equal to this as a level 1 problem. And another problem they ask you show this, in another problem ask you show this. So this problem is a combination of some E-level problems, yes? So that is the skill that you need to learn, especially in this course. You need to improve this skill in you, that you are able to break down the hard problem to smaller pieces and try to solve each piece at a time, and then be able to combine them back to solve the hard problem. Okay? So it doesn't matter what you want to do in the future. If you want to have a good job with high salaries, you need to improve problem solving skills. And of course, the math lessons are the best place to do that. So you need to improve your analytical skills to think analytically and be able to solve the problems. So you might think that this is a horrible problem, but to be honest, it was not that hard. So you need to break the problem down. So for example, if you're interested, I don't want to go through this. I will consider this a hard problem a little bit more. So you have to be also creative. I don't want to go through it, but you can take a picture or whatever. I can put this file somewhere for you if you are interested in. So that would be a little bit harder problem. Okay, any questions here? Yes, please.
Is there another way to solve this problem?
No, I don't know any other way. Yes. Of course, I will not go through the unit circle because I have worked with these things, I have them in my head. And I want actually, that is the part of the other part of the lesson. So in the book you will see these formulas. So I don't know if I can check it. Let me ask you some question. Can you tell me how sine of negative an angle and cosine of the same angle are related? And I want to ask the same question for cosine, and I want to ask the same question for tangent. Of course, tangent does not have an independent identity, yes? If you know what sine, how sine will change, how cosine will change immediately, you can tell how tangent will change, because tangent is nothing except division of sine over cosine. Yes? Okay, so how they are related, can you visualize it in your head? Try not to draw it. I will draw it and teach you, but in your head, can you see how they are related? Imagine an angle, imagine it's negative, and see how sines are related, how cosines are related. Can you do it in your head? Yes? Anyone who wants to answer? Yes, please. Yes. What about sine? So what? Yes, is that understandable for everyone? Because you don't need to imagine all cases. You just imagine one case, for example. Of course, you have to convince yourself this is working for all cases. But let us say this is theta. Yes. And then where is minus theta? Minus theta is here. Okay. So if I ask you what are the coordinates here, you can tell me coordinates are cosine and sine. Now, can you read the coordinates here? Yes. What are they?
Cosine
Cosine is the same.
yes,
The x-coordinate is the same, but the y-coordinate
is negative.
is negative, yes? So this means that you have a formula. Okay, and it's a very important formula. So if you have sine of a negative angle, you can pull the negative sign out. Okay? But if you have cosine of a negative angle, you can immediately just get rid of that angle. Yes? What happens for tangent? Anyone else? So tangent is this divided by that. Okay, so if you divide this by that, sine, cosine becomes tangent, but minus sine will remain. Okay, so this becomes negative as well. Okay, so this is important. Write it somewhere. You don't need to memorize it, but at least you need to be familiar that there is something like this. So in case you need, you can use it. Okay, so I can say this is the trigonometry of opposite angles. Trigonometry of opposite angles. Okay, for example, can you use this idea and some ideas you learned before, convince me about this without the unit circle? Why cosine of 110 degrees should be negative of sine 20 degrees without the unit circle again, using these formulas that you see here and what you had before. Yes?
Aren't they complementary angles?
Which angles?
The 110 and minus.
Yes, so 110 degrees and minus 20 degrees are complementary. Do you agree? Why? Because when I add them, it becomes 90 degrees. Now my question is that what is cosine of 110 degrees? We learned before that if I have a pair of complementary angles, cosine of one of them is equal to what?
The sine of that.
Is equal to the sine of the other one, but the other one is negative to 20 degrees. But we just learned that if sine contains a negative sign inside, I can pull that negative sign out. So this negative sign goes out, it becomes minus sine 20 degrees, and that is exactly what we got using the unit circle. Okay? Okay, now let me ask you this question. Yes. How, if I ask you, can you give me the supplement to 120 degrees? What's your answer? Do you remember this is the word that we learned today? Supplement, everyone say it.
60 degrees.
60 degrees. Okay, now if I give you theta and I ask you to give me the supplement, what do you say? 180 minus theta, yes? So if I ask you what is the supplement to theta, you will tell me 180 minus theta. If I ask you what is the complement of theta, 90 degrees minus theta. Is that understandable? Okay. Now, my question is that, is there any relation in general for this one and that one? Do you think they are somehow always connected? Not for special cases. Do you think these two numbers, one for theta, one for its supplement, are always connected? Yes or no?
Yes.
How?
The other one's the negative.
How many of you agree? So you are saying that this one is negative of this one?
Yes.
Yes?
Yes.
How many of you agree with that? Yes? How many of you agree with that? How many of you agree with that? How many of you disagree with that? So what are the other people doing? Yes. So agree or disagree? First, agree, raise your hands. Okay, disagree? What is the correct one?
Is it just
Equal. Okay? So here, in mathematics, democracy doesn't work, yes? You cannot just vote for which one is correct, yes? So here, because you are probably confusing the x and y coordinates. So if this angle is theta, okay, where is 180 minus theta? Everyone, I think, realized where is it? Where is it? Exactly where? Do you agree? Here. Because if I do that, by symmetry, this angle is theta, this angle becomes also theta. So this angle becomes 180 minus theta. So they are mirror image of one another, not with respect to the x-axis. The people who said minus, they were thinking in that way. They are a mirror image of one another with respect to the y-axis. So if I ask you what are the coordinates here, you will tell me cosine theta and sine theta. And then I would say that this is the mirror image of that one. So what are the coordinates? Minus cosine theta and sine theta. Now I am asking you about the sine, so you are interested in the y coordinate. So that's correct. Okay? If I ask you the same question for cosine, everyone on 1 second. Yes? What's the answer?
Negative.
Negative cosine. Agree or not? Okay, now 2 seconds. What is this answer?
Negative also.
Because tangent means this one divided by that one. So if you divide this one with that one, this becomes tangent, but minus sign will survive. So it becomes minus tangent. Yes or no?
Yes.
Okay. But now let me try to tell you something else. So what happens if I ask you, what is sine of 180 degrees plus theta? Of course, you can start from scratch. You can go and understand it in that way. But this is not my intention. I want to teach you something else, okay? So how can I use the trigonometry of supplementary angles? This is the trigonometry of supplementary angles. And the trigonometry of opposite angles to say something about this. Yes?
Isn't it equal to minus sine theta?
Why? Using these two ideas, yes? If I ask you, can you tell me, by the way, let me test your understanding. I'm asking you, what is the supplement to this angle? What is the supplement? What is the supplement to this angle? How do you process my question in your head? When I say what is the supplement to this angle, I am asking, can you give me an angle so that when I add that angle to this angle, the sum becomes 180 degrees. Do you understand what I'm saying? Yes or no?
Yes.
Yes or no? Okay. So what is that angle that when I add to this, it gives me 180 degrees? Yes?
Shouldn't it just be 0?
No, if I add 0 to 100, this is the total angle. If I add 0 to it, what is the answer again? 180 degrees plus theta. Okay, so that is not the correct answer. So what is the supplement to this one?
Minus theta.
Minus theta. Yes, because minus theta, when added to this angle, it gives me what? It gives me 180 degrees. Okay, but we just learned that if two angles are supplement of one another, sines are equal. Yes, so this means that sine of 180 degrees plus theta is equal to the sine of minus theta. Yes? So don't memorize them, because this is the bad habit. This is why the students don't learn mathematics. They think that this formula is talking to you. So you should be able to express the formula in English or in your own language. Can you, one of you, please read this in English? Not like this, sine of 180 degrees minus theta is equal to sine theta. This is not. Just give the message of this formula. This is important. These are, by the way, skills you can learn. Even if you learn these things, mathematics is still hard. Okay? Let alone you don't respect these things. Okay, can you read in English, what is the message of the formula on top? So you see, you don't have this skill. This is something you can learn. This is not hard. For example, let me make a question simpler. So let us say that now your brother, your sister, whoever is in the first year, they are asking you about this. Okay? You have this formula. How do you explain this formula to your sister or brother? Of course, you say that, look, a plus b to the power of 2 is a squared plus 2ab plus b squared. It doesn't work. You need to give a recipe. This is telling you something. It's talking to you. You need to learn the language. What does this mean? So, for example, this tells you that if you have the sum of two numbers and you are interested in squaring the sum, the answer becomes the square of the first one plus 2 times the first one times the second one plus the second one squared. So this is the message of this one. So it means that you are also telling when it is useful. You need, because there are millions of formulas, you cannot, even if you have a handbook of all the formulas, where do you want to look for? So you need to understand when this formula is needed. It is needed when I have two numbers, they are added, and I am interested for some reason to square the sum. Yes? So that's the way that I use it. So can you now read this one? What is the message of this formula? Yes, please?
And when you take the sine of 180 minus any angle, is equal to the sine of the same angle.
Yes. But can you use more English words? For example, let me probably if someone tells you, do you agree with this one? First of all, tell me yes or no. 1 second. Why? What's the answer? Why?
Supplementary.
Because they are complementary. And you have something in mind. Because this is, by the way, you were able to answer this immediately because you learned what I told you in English. Yes? Because I told you whenever the sum of two angles are 90, it means that's complementary. And we learned that the sine of one angle is equal to the cosine of its complement. So this is a good way of learning. So what is the message of this? This angle and this angle they have a name in mathematics. What are they? Supplementary. So what can we say? We can say the sine of supplementary angles are equal. This is the message of this formula. So it is giving you this message. If you cannot read this message, then you will not be able to solve harder problems. Because you can only solve that problem which is exactly this formula. If it deviates a little bit, then you are confused. So this is the message of the formula, yes? Okay, can you read this in English again for me? What is the message of the second formula?
The cosine of the supplement is negative.
Cosine of supplementary angles are opposite. Yes? Read the third one, practice. The tangent of supplementary angles are opposite. Okay? Okay, now let me use this sentence. Can I write this or not? Can I write this using the message you got from the first one? What was the message? The sine of supplementary angles are equal. Using this message, can I write such a thing? Yes or no?
Yes.
Why? Because this angle and that angle are supplementary. Why? Why?
They add up to 100.
They add up to 180 degrees, yes? So now I have two angles which are supplementary. The message of this formula is important, not the formula itself, yes? The message tells you that if you have two supplementary angles, then the sines are equal. But if you are learning mathematics, you had another message for this one. Yes, what was the message? I erased that. Sine of a negative angle is equal to minus sine of the angle. So this means that I can pull this out minus sine of the angle. So this means that you were able to immediately find this formula without any troubles. Okay? This is extremely important, by the way, because I know that you haven't learned mathematics in that way probably from the beginning. So it is a little bit hard in the beginning, but if you really listen to what I'm telling to you, don't get tired, okay? Because I don't know, I cannot read your faces. You haven't been my student before, so I don't know, are you happy or you are sad or whatever. But even if you are sad, you have to adapt yourself with me, okay? Yeah? So you have to adapt this, because otherwise you will not be able to solve problems in the national exam. Is that clear? If you don't read the messages of the formulas, and just memorize them, because I have seen that, whatever. When I give an exam, people are paging the formula sheet up and down, okay? It doesn't work. Okay, you need to have a strategy, you need to understand what is going on, and then go right to the formula. By the way, in Math 5, there are 10 pages of formulas. So if you really don't know where to look for, the whole time for the exam will be paging the formula sheets. Yes? Okay. Any questions here? Please.
When you wrote cosine 180 minus theta equals to minus
Yes.
cosine, but minus theta is not the complementary to the previous angle.
No, it's not. No, this we didn't discover using this idea. These formulas we discovered using this. Okay? But I am telling you that if I ask you this for plus, okay, you don't need to do it again using this. Of course, you can do it again using the unit circle. But I just want to draw your attention to different ways of coming to the same conclusion. This is important, by the way. For example, if you want to go from one place to another place, if there is a traffic in one road, of course you can change the road and go to the other way. Okay, it's always possible. So it is important to, my goal is to play around with the concepts so that these concepts get implemented in your brain and then you can use them. Okay, and I really recommend you, please do not underestimate the role of the memory. And this is, so